Hey guys, wanted to demo something kind of cool I've been working on in the Dreamscape engine. When I first started, I wrote everything in C++, and I realized that for some things it was useful to have a scripting language. So I brought in AngelScript. And originally we were just using AngelScript for the cutscenes and things that were kind of like incidental to gameplay, just because the scripting language would be simple enough to convey those things. But something that's been slowing down development a little bit is every time I have to make a change to something, I have to recompile the engine and the editor. I basically have to rebuild the code and then run it, test it, and then once I've tested it and I want to tweak it, I have to close it, go change the code, compile it, and run it again. And it's really slow. So I thought it would be really useful to have basically hot code reloading so you can run the editor and the game and then basically write AngelScript to write the code that usually you'd be writing in C++, just write it in AngelScript instead. This is just going to be a quick demo. I probably will make mistakes because this is quite new, but I wanted to show the development workflow for this. Here we have just the default room in the dungeon, players up there, and in our outliner over here, we can see that you can select this room, and if you right click that, we can add a scripted entity. So we've got ghost.as open over here, and you'll see as well it says after I've added that scripted entity, no class and module implement scripted entity. That's because it's just an empty file. What I can do here is subclass scripted entity like that, and then rebuild. And now it says it can't prepare the call to init or to process. So I basically just need to do this. I will make these error messages a bit clearer. This is still kind of early days for this system. So rebuild now. And that was fine. So I'll clear the console and rebuild. You can see no errors were encountered while building. And now just to kind of drive it home, I could even print and say like init called, and in here I could say process called. So if I do rebuild, you see init's called. If I hit play, process is called a whole bunch of times. The next thing would be to actually give this entity that we've created some visuals. Right now it's invisible in the world. What I'm going to do is I'm creating a ghost entity. I've basically got a couple meshes and textures and stuff set up when I was trying this out before. So the first thing to do is call these things. So we've got init render data. So we tell it that the render data for the scripted entity is a mesh instance. Currently we're using file names for the mesh and the texture. In the future we're going to be using assignments that's a bit closer to what Unity would do, but for now we're just doing it this way. So I think that should be enough for us to at least see the entity. So if I rebuild again, okay, so we the entity is really big. If I hit play we should be able to see it. Yep, there we go. So if I walk over here you can see this massive ghost entity. It's just because the way we exported the model it's way too big. This is actually a pretty good example. I can pause. In fact, I don't even need to pause the game. I can keep the game running as long as the goblins don't find me, because there are some goblins in this level. But while this is running, I can go over to init and I could run set scale and then just set a smaller scale and hit rebuild. And now it's much smaller. I'll get rid of the process being called every frame because that's gonna spam the console. So you can see now that down here he's a lot smaller. The next thing I'm going to do is add an animation to him so that you can see his walking animation. I'm actually just going to pause it and get rid of these goblins because if they find me while I'm testing it's going to be really awkward. So here we go. Now I want him to animate. So the way we're going to do that is I'm going to add a walk animation asset. I'm going to pull this from my pre-written code, but basically it's just a member variable walk anim, and it's just a string for the walk animation. And then down here when we're assigning these, I can just do set animation by file name, pass in the walk animation, and then now, there we go, we can rebuild. Now he's got his walk animation assigned. But you'll see that even though it's assigned, he's not moving. That's just the first frame of the animation. So in process, we can do set anim time to get anim time plus delta time. So that's basically going to just tell it to animate. There we go. He's gone a bit fast. So let's slow him down. Let's go half speed. Okay, still just a little fast. I feel like 0.4 might be about right. There, that's probably cool. Let's do that. All right, and next thing I'd like to do is make him turn towards the player. So to do that, I'm just going to basically I need to grab the player. So right now he has no knowledge of where the player is. This is where things get a little interesting. There's no way right now for this class to like automatically have access to gameplay systems. It's basically just got access to engine systems. We have included some of the gameplay types, but just not the systems. So basically that means that we have to manually grab the bits from the scene that we need. What I can do here is just create a handle for the room. I'm going to create another handle for the player. And technically this doesn't need to be a player, it could be any entity. So I'm just going to call it target. So we've got the room and the target that we're going to go towards in init. The next step is just to hook up the room entity. So what we're going to do here is we've got a function called find ancestor. And what that does is you give it a callback function, like a predicate with a handle to an entity. And then you return a boolean to say whether the entity it's given you is the one that you wanted. So I'm just going to say if it's of type room, then it's the entity that I want. And then we're going to cast the result of that to be a room because it's just going to give me an entity. And then we're going to assign our room handle to the result of find ancestor. And that should give us a room. If that worked, I should be able to do if room not is null, like this. And then we can go found room. So clear console, rebuild. All right, so yeah, init called found room. So this was able to basically call find ancestor, which is just going up the hierarchy from the scripted entity until it finds something of type room. It doesn't have to go far. It's basically going to just find it immediately because it's the direct parent. But it's possible that this script could be added as a sub-object of a sub-object, so find ancestor is more robust. So there we go. We now have the room. So the next step, from the room, we want to get the target. But we only want to get the target if there isn't currently a target. So what I'm going to do here, I'm just going to copy some pre-written code, but the idea is that if the target is currently null and the room is not null, so we found a room in our init function, we will call find descendant, which works exactly the same way as find ancestor, but it goes down the hierarchy instead of up, and we're calling it on room. So we're going to look at everything below the room, and we're looking for the first thing that we encounter that's of type player. So right now there's only one player. This will be fine. For co-op mode, we'll have to look at targeting a little bit more carefully, but this will work fine here. The next step would be if we have a target, well, I just want to see, have we got a target? So if we ever get a target, if target not is null, then print got target, and then in print we can just add the target here so we can see it. So if I rebuild now, you can see got target entity 426 player. That's our player entity. All right. So the next step is to make our ghost follow the target entity so he'll turn to follow you. So again, I've got some pre-made code here that should do the job. He needs to have an angle in his gameplay state. So up here, just put an angle up there, and then we can use that angle to determine which way he's facing. The way that we calculate that is using atan. I'm going to need to grab the direction towards the target. Direction equals target.getPos get position minus our get position, and then normalize it, and that's our direction that we're going to go towards. Let's try that. Okay, that seemed to work, but yeah, I'm not using the angle variable yet, so we actually need to set our rotation. So we do set rotation. Now all rotation in the engine is done using quaternions. So we want to define the axis, which is just the y-axis, like around the vertical axis, and then we want to pass in the angle. There we go. And now he's turning to faces. And the cool thing is I've been able to build all of this logic without ever having to go and rebuild the editor. I haven't even had to stop the game. Like while the game's running, we can just change the code. So if we want to give him a slightly more elaborate behavior to make him actually move towards the player, I am just going to copy and paste a pre-made class now just to show you the full implementation. So this is what I did last time. It's not perfect, but basically we have following and attacking states up top. We've got cooldown constants or attack constants up the top here. The cool thing is that these are local to this module, so like it's fine for them to be globals. They're not really globals, so you can just put constants and types and stuff up the top. But other than that, we basically have in our process function a switch statement on our current state. If we're in the following state, we'll increment our timer to see how long we've been following for. And if our vector towards the player is less than 1, which means we're close to the player, and our timer is more than our attack cooldown, so we're ready to attack again, we clear out our timer, we print attacking, change our state to attacking, set our animation to the attacking one instead of the walking one, and then we break out. Otherwise, if we're just doing normal follow, we basically normalize our direction and just move towards it by a determined speed, and we slow down the speed as they get closer. So we'll kind of chase you more until he gets closer. So if we rebuild that, go towards you. Now the speed of this is kind of different, so you can see it's a little crazy. His animation speed is a lot higher in this example. So I'm just going to pause this and figure out his animation speed here. Let's see. Yeah, so here we're adding delta time. I could probably multiply that by like 0.4. That's a lot better. You can see like his tail moves more sensibly. But you can see that the attacking animation is a little glitchy. It's like as he's getting close, it's kind of like it's not resetting his animation time. So what I'm going to do there is every time we change state here, I'm going to do set anim time to 0. Because we're changing, it's actually because we're changing his animation. We'll set it back to the beginning of the animation. And we could certainly code this in a cleaner way, but this is just to get it working. Okay, it's close to you. It seems like he finishes with his attack animation way too soon. So if I pause this, I can actually come right in here and then advance 1 frame each time, see what he's doing. So I'm going to clear the console so we can see any state changes. So he's just following just now, I think. He should change into attacking when he gets super close. There we go, attacking. And then he starts his attacking animation. Yeah, and he goes back into following way too soon. And his attack animation is over before we know it. So it's actually what we need here is this animation speed needs to be variable. So we can go anim speed there. It just needs to be a local variable, I think. So we'll just go float anim speed equals 1.0. We're using it down there, and then only if we're in the following state, we'll set the animation speed to be 0.4. Then rebuild. Okay, it's different, but not quite better yet. So his walking is still fine. Like his main kind of idle animation is fine. But if we come back in here again and advance the frames, it comes up and goes down. I mean, it's definitely better. Like he does get through more of the cycle, but it does look like before he does his attack, he's got this little kind of, it kind of goes back, comes back down. That might just be the way that the animation is defined. We might just need to improve that. But it definitely looks like he needs to be in his attacking state for a lot longer as well. Like, it's running pretty fast just now. He's over before he should be. So we're going to change the attack duration to like 1.5. Okay, it's kind of bouncy looking, but feels closer to a real attack, right? And again, we can come in here and tweak it. Let's just advance through, and then we'll wait for it to start. So he goes back like that, and he goes up, down. Okay, the duration I think still needs to be a little longer. Let's put it to 0.8. Up and down. There we go. That's looking, oh, that's maybe like a little too much because that is all just one cycle, right? What I'd actually do here is change the animation speed to make that slower, and we might end up being at 0.4 for both of them, actually. And again, this code's messy, but we definitely do something cleaner. This is just for kind of discovering what values things should be. So going up, going down. And that might look a bit better. It's not quite there, but the start of his animation is better, but it kind of gets cut off before he comes down for this strike, right? So that just feels like his, again, the actual timer needs to be a bit higher. Now I've made the animation slower, the attack duration needs to be higher if it's going to get through the full cycle. What if we made the duration like 2.5? It's looking better already. I do feel like the start of his animation gives him this kind of wind up, which isn't necessarily a bad thing, but it's very easy to dodge right now. It's like very punishable. What I'd probably do there is try and change the speed of the animation up until a certain point and then fine tune it. But that's probably enough to show you the concept for this recording, right? I'm pretty happy with it overall. There's still quite a bit more work to do in terms of making the engine systems available to the scripting language, but compared to where it was before, where every little change I was making would need to be rebuilt, this is a lot nicer. But yeah, that's it. If you've got any questions about the engine or anything that you're interested in discussing, just let me know. Cheers.